Okay guys, in this section 5-6 we're learning about linear and angular speed. Linear and angular speed. Okay, so the first concept that we come to is arc length. And so to get to arc length, what we start with is the radian formula. So remember, the angle, right, for radians is equal to S, which is the arc length divided by the radius, right? So the arc length divided by the radius is radians, right? So if you just take this equation and rearrange it, you can come up with this equation. The arc length equals to the radius times the measure of the central angle. So for arc length, if you have the radius and you have the central angle, then radius times the central angle, that equals the arc length, okay? And our angle here is measured in radians, and so that's kind of what we're looking at. Then, of course, if the radius is 1, you plug a 1 here, then the radian measure equals the arc length. Okay, so we have a few that we're practicing finding the arc length now from this formula. And so a circle has a radius of 4, okay, and the central angle is 240. And so what we want to find here now is we want to find the arc length. Well, again, from this formula, S equals, remember, R is the radius, there's 4, times, all right, so 240. Now, remember, for purposes of this formula, the angle's measured in radians. So if I've got degrees on arc length, I want to change that back to radians. And so if I just go off to the side here and then do 240 times pi over 180, right? Remember that? Then I could see, as far as radians is concerned, that's 4 pi over 3. And so I'm going to plug 4 pi over 3 in for my radian measure of my angle. So when I multiply that out now, then that's 16 pi over 3. So that's my arc length. Now, you can express it in terms of pi, or you can multiply that out and get a decimal, which is 16.76. Okay? And then the unit of measure for my arc length would be the same as the unit of measure that the radius is given in. So that's inches. So 16 pi over 3 inches, or 16.67 inches would be the answer. Now, you can see arc length expressed either way, in pi or as a decimal, either one. So be prepared for each one of those. Your answer choices could be either way. Okay, so a couple more now. We're finding the arc length. So once again, remember, the arc length equals the radius times the central angle. And so for the first one, 9 feet, 60 degrees. That's going to be S is equal to 9 times. I want to change 60 to radians, which is pi over 3. And so that would be equal to 3 pi. Or if I make that into a decimal, that'd be 9.42. All right. The next one would be 27. And the unit of measure, by the way, feet here. 27 times 2 pi over 3. So when you guys multiply that out, you'll get 18 pi. And you can change that to a decimal and get 56.55 meters is the unit there. Okay, so remember, you can see arc length expressed either way. The important thing is make sure you're plugging in radians. For this formula, requires the radian measure, not degrees. Okay. Now, the next thing that we come to is we come to linear and angular speed. Linear and angular speed. Okay. And so the arc length, that formula can be used to analyze the motion of a moving particle that's moving at a constant speed along a circular path, right? And so we've got two formulas here. So first of all, consider a particle moving at a constant speed along a circular arc of radius r. S is the arc length of the arc traveled in time t. Then the linear speed of the particle is given by this formula. So the linear speed is the arc length S, we know how to calculate that, divided by the time. That's the linear speed, all right? And if the angle has to be in radian measure again, is corresponding to that arc length, then the angular speed of the particle is going to be whatever that central angle is divided by the time. All right? So we have linear speed, right? So if it's moving around, you can calculate what the linear speed would be if it was going along a straight path, right? But you can also calculate the angular speed, like how many angles, in other words, is it covering per a certain amount of time, right? So let's just jump right in and do a couple of them. Okay, so what we've got here is a 15-inch diameter tire on a car makes 9.3 revolutions per second. Okay, so we want to find the angular speed in radians per second first. All right, so for A, we're trying to find the angular speed first, right? We want to find the angular speed. So the angular speed formula is going to be the angle divided by the time. The angle divided by the time. All right, now, here's what we got to think about. Okay, if it goes 9.3 times per second, if it turns 9.3 times, we've got to try to convert that into a radian angle measure, right? So we want to see what is the angle for 9.3 times turning around the circle, right? So to figure that out, my angle is going to be 9.3, and then it's going to be times, right? It's going to be times 2 pi. Because remember, all the way around the circle, one revolution is 2 pi. So 9.3 times 2 pi, that would be the angle for 9.3 in radians for 9.3 times revolutions around, turns around, right? Because one full turn around is 2 pi. 2 is 4 pi. Well, 9.3 revolutions is 9.3 times 2 pi. And then over, so it's per second, so that's just per 1 second, right? And so once I multiply that out, that's going to be 18.6 pi. 18.6 pi revolutions per second. Okay, that's the angular speed. That's the angular speed. Okay, in other words, how many radians is it covering per second? That's what angular speed shows you or tells you. All right. So we're taking that and converting it now to the angular speed. So how can we take this now and find the B part of it? And yep, that's radians per second. And so now to find the other part of it, the linear speed. So it's not how many radians is covered per second. Linear speed is going to ask us now how many, let's see, revolutions, inches, how many inches per second. So inches is the unit of measure here on this one. All right, so remember, linear speed is the arc length divided by the time. The arc length divided by the time, not the angle divided by the time. It's the arc length now. So remember, how do we find the arc length? Well, remember, on the other page, arc length is going to be the radius times the angle measure. So we can immediately convert S to radians times, radius times radians over time. So I'm changing the arc length S to radians times radius, R times theta, equals. All right. So the radius, well, if the diameter is 15 inches, then the radius is going to be 7.5, right? So that'd be 7.5 times. Now I need the angle measure in radians. Well, didn't we already calculate the angle measure for 9.3 revolutions? Yes, we did in the other problem. So I can now, if it's the same problem that wants angular speed and linear speed, you can take the angle that you got there, because this is not going to change from the first problem if it's the same problem asking for both speeds, right? So now I can take the same theta that was here, which is 18.6 pi. Okay, so there's no change there. And then this is now all going to just be divided by 1, right? Because the time is per second that I want. And so once we multiply this thing out, then we are going to have 139.5 pi, right? Or if you wanted to, since it is linear speed and we're talking about a distance now, then you could also take that and turn it into a decimal if you needed to. 438.25. And in both cases, this is inches per second. Inches per second, right? So that is your unit of measure, inches per second. Okay, so again, we use the same angle measure from the angular speed in order to take it and turn it into linear speed. Okay, so for a 15-inch tire that makes 9.3 revolutions per second, the angular speed is 18.6 radians per second, but it's 139.5 pi, or 438.25 inches per second. And just like with the arc length could be expressed as pi or as a decimal form, same thing with linear speed. It can be expressed as pi or in decimal form. Now, the angular speed is going to be typically in pi. I guess it could be expressed either way, but it's typically expressed in pi because of the fact that it's measured in radians. But this one could be either way. You could see this as a multiple choice, or you could see this. So be ready to convert between the two. All right. Now, for this next one, we have a little bit of an added twist. Okay, so it says the circular blade on a saw has a diameter of 7.5 inches and rotates at 2,400 revolutions per minute. Now, look at this. Okay, it says find the angular speed in radians per second. Now, here's the very first thing that you should notice. Okay, the problem's given to us in revolutions per minute. It's asking for speed in radians per second. So we've got a change of units here that we have to account for. Okay, so before we even start, we want to convert 2,400 revolutions per minute to revolutions per second. So how can we do that? Well, we just need to take 2,400 and divide it by 60. And so that would make 40 revolutions per second. So 40 revolutions per second is what I'm going to use to calculate the angular speed. And so angular speed, again, is going to be equal to theta over time, right? Equals. And so remember, when we're talking about the angle, right? Okay. Remember, it's 40 revolutions per second, so it's turning 40 times around per second, and then I have to multiply that by 2 pi because every time around is 2 pi radians. So remember, angular speed is in radians. So like in the last one, we did 9.3 revolutions times 2 pi. Well, here we're doing 40 revolutions per second times 2 pi. And again, this is still going to be over 1 because it's per second, right? And so now we are going to multiply that out, and we'll get 80 pi revolutions per second. 80 pi revolutions per second is what we've got there. Okay, so now we'll use that and see if we can calculate the linear speed. But now we also have a conversion to make on linear speed. We also have a conversion to make on linear speed because it's asking for to find the linear speed in feet per second. Okay, but what's the diameter given to us in? Inches. So I'm going to have to convert, right? I'm going to have to convert inches back to feet. I got to convert inches to feet. Okay, now remember, I need the radius for this formula, right? Because it's S divided by T, which is the arc length. But what's the arc length formula again? It's the radius times the angle measure divided by time. And so the radius is now what I need to make sure that I'm looking for and plugging in. Okay, so now, here's the deal. Okay, if the diameter is 7.5 inches, then the radius is going to be 3.75 inches. But remember, I need to turn inches into feet by dividing this by 12. Okay, so I'm going to take that and divide it by 12 and make that 0.3125 feet. Okay. All right, so now I've got the radius in feet. Okay, I've got the radius in feet. First of all, I had to cut it in half because it was diameter to radius. Then I got to take the radius and divide it by 12 to turn inches into feet. So this is what I'm going to use for the radius. So now that we've got our conversion made, I've got 0.3125, all right, times, remember, I already calculated the angle, which is 80 pi And I can divide this now by time, which is 1 per second. Okay, so when I multiply that out, then we're going to get 25 pi. Or you could turn that into 78.54 since it's linear speed. And then in both cases, this is feet per second. Feet per second is the correct answer there. All right, so there you go.